Hi, welcome to your first video for topic 8. Topic 8 is called equations. So 8.1 is really nice. Because of the way we've set up class, you've kind of already been being taught it through stuff we've been previously doing. So you don't even really know that you have been being taught this information. So 8.1 is solving simple equations. So these are kind of one-step equations. So you should be able to do these super easy because we have solved much more difficult things in class. To do this, we need some basic vocabulary. So let's start with variable. What is a variable? Well, a variable is a number used to represent an unknown quantity. So typically we use X or Y. We talked about this in our last topic. Another one would be isolate. So a good way to help you remember this is the random facts of the day are isolated information. I have no additional information that connects to them in any way, shape, or form. I just know there's one isolated thing that kind of floats around by itself. So that can help you kind of infer the meaning of isolate, which means to get alone. So when you are solving an equation for a variable, your goal is to isolate the variable. That is your goal. Once you get just X by itself or just Y by itself, that's the step where you have isolated the variable. The last one is inverse operations. This is actually a 6th grade vocabulary word, but some of you are a little rusty on this. An inverse operation is how you undo a given operation. So just also another reminder, basic operations, addition, subtraction, multiplication, and division. So how do you undo addition? Well, that's subtraction. How do you undo subtraction? Well, that's addition. So addition and subtraction are inverse operations. Similarly, multiplication and division are inverse operations. All right. So this is going to be a short flip video. I'm going to do one of each style of problem. So the first one we have is an addition problem, then we'll do a subtraction, then multiplication, then division. So just really easy. A plus 2 equals 10. So how do you get A by itself? We're going to subtract 2 from both sides, and those 2's cancel out, so you're left over with A equals 10 minus 2. Now what's 10 minus 2? A equals 8. Now that final step where you say A equals 8, that is the step where you have isolated the variable, where you have solved for the value of that variable. All right. Now, because we have already done previous topics like 4 and 5 with addition, subtraction, multiplication, and division of rational numbers, so of decimals and fractions, it's expected that you're able to do that. So if I gave you A plus 2/3 equals 10 over 50, it's expected that you're able to do that, all right? So if you need to brush up on those skills, that's something that you need to do. Similarly, we've already talked about adding, subtracting, multiplying, dividing positive and negative numbers. So I could take it one step further and say A plus negative 5/8 equals negative 4/3, and you should be able to tell me what A equals. I'll actually add that to the end really quick, all right? So these are these are the basic steps, but it could easily tie into previous knowledge that you have. All right, so I'm just doing very baseline, basic problems. All right, here let's do a subtraction one. B minus 5 equals 23. Well, what's the inverse operation of subtraction? Well, it's addition, so I'm going to add 5 to both sides, so those 5's cancel out. And I get B equals 23 plus 5. Now, what's 23 plus 5? 28. So B equals 28. All right. C times 10 equals 120. So this kind of looks weird. We'd never write it like that. You'd be more likely to see 10C, because C times 10 is the same thing as 10C. They mean the same thing. So C times 10 means 10C, so I can change my equation to say 10C equals 120. Well, how do you undo multiplication? That's division, and I divide by 10 to get rid of those 10s. What do I have left over? C equals 120 divided by 10, which I can rewrite as 120 divided by 10. Just a brief reminder, your numerator comes first if you write it sideways. So the numerator is 120, so 120 comes before the division sign. Denominator comes after. So 120 divided by 10, C is equal to 12. All right. For division, I have to split it up into 2 categories. So the first one will be if your variable is in the numerator. So this would be like D divided by 12 equals 200. Well, how do you get that D by itself? You're gonna multiply both sides by 12, because the inverse operation of division is multiplication, so we're going to multiply both sides by 12. Now you'll notice I kind of write it up in the numerator spot, and that's not by accident. It's because I know that 12 is really 12 over 1. So I'm really multiplying d over 12 by 12 over 1, but I'm not going to show that step. I just want to let you know where this comes from. That 12 in the numerator and that, or let's multiply the other side by 12 as well. That 12 in the numerator and the 12 in the denominator cancel each other out. So they reduce to 1 and 1. So you have now a fraction, 1 over 1 times d over 1. Well, 1 times d is 1d, and 1 times 1 is 1. So really this gets you to 1d, 1 over 1d. Here, let me change that really quick. It's really 1 over 1d, but we don't write that. That doesn't look right to us. We don't write that number in front, so we just get rid of that 1 over 1. So we're given d is equal to 200 times 12. That's easy. Now we can just do 200 times 12, so d equals 2,400. All right? So you don't have to show that step with the 12s canceling each other out and all the 1s. I just think it's helpful for you to realize that I'm not just canceling numbers out. Like, they go somewhere. Like, there's a reason, there's a mathematical reason why they're not there anymore. All right, the last example would be, let's say 100 divided by d equals 25. So in this example, your variable's in the denominator. So there's two ways you can approach this problem. The first one would be cross-multiplying. I might know this might be a little bit of a while since you've seen this method. So you need a proportion. You need one fraction equals another fraction. So we can change the 100 over d is already a fraction. I can change 25 to 25 over 1. And then you multiply one numerator by the other denominator and one denominator by the other numerator. So 100 times 1 equals 25 times d. Well, 100 times 1 is 100. 25 times d is 25d. This is a much easier system to solve. So how do you get d by itself? Well, it's 25 times d. How do you undo multiplication by 25? You divide by 25. So you divide both sides by 25. The 25s cancel. You're left over with d equals 100 divided by 25, which is 4. So d is equal to 4. The other way I'm going to call roll with it. There's no really mathematical term for this. It's just kind of go with the flow. So what do I mean by that? Well, if you have your equation, 100 divided by d equals 25. Let's just multiply by whatever the denominator is. So the denominator just happens to be d. So let's multiply both sides by d and see what happens. So if I multiply both sides by d, on the left-hand side, d, so if you look back to the problem over here, you know, if you're multiplying two fractions and one number is in the numerator of one fraction and the denominator of the other fraction, they cancel each other out. So those d's on the left-hand side are going to cancel each other out. So what do you have left over? You have 100. Now 25 times d is 25d. That's an easy, we can work with that equation. So 100 equals 25 times d. How do you undo multiplication by 25? Divide both sides by 25. You get d is equal to 4. So let me section those off. All right? So no matter how you do it, you get to the same place. All right? Really quick, before we talk about that one last problem, how do you check your answers for all of these? Well, you can go ahead and take the answer that you have and plug it back into your original equation. So I'll do those really quick. So if you take that equation, a plus 2 equals 10, take that 8, plug it into the a spot, 8 plus 2 equals 10. If it's true, if you got it right, you'll get a true equation. Well, 10 is equal to 10, so it's true. For the yellow, 28 minus 5 equals 23. Well, 28 minus 5 is 23. 23 is equal to 23. Therefore, it's true, and I got it right. For the green one, 10 times 12 is equal to 120. Well, 10 times 12 is 120. 120 equals 120. Boom, got it right. Light purple, 240, because I got d is equal to 240. 240 divided by 12 is equal to 200. Well, 240 divided by 12 is 200, so 200 equals 200, so I got it right. I unfortunately don't have room in the bottom right-hand one for when your variable is a denominator, so let's scoot it up here. 100 divided by 4 equals 25. Well, 100 divided by 4 is 25, so 25 equals 25, so you know you got it right. All right, so I mentioned that I want to do one of the more difficult problems. Oop. So let's make one up really quick. Let's say you have the equation x plus negative 1 3/4 equals, I'll throw parentheses around that, 5 over 11. Okay, so let's break it down. What's your symbol between the x and the number? Well, it's a plus sign. That's too dark. So it's a plus sign. So what's the inverse operation of addition? Well, it's subtracting. So I'm going to subtract. Now, I'm subtracting a number. That number just happens to be negative. So I'm going to subtract negative 1 3/4. I'm going to subtract negative 1 3/4 from both sides. So these guys on the left cancel each other out because I have plus negative 1 3/4 and then minus negative 1 3/4. So it doesn't matter that they're negative because I'm adding and subtracting the same number. So those cancel out, so what do I have left over? I get x is equal to 5/11 minus negative 1 3/4. So now this is just a combining fractions problem. So let's change the minus and negative to add a positive. So this gets me to x equals 5/11 plus, right, negative, negative, positive, positive, 1 3/4. Now, how do you combine fractions? Well, you need them to both be fractions, not mixed numbers, so let's get there. So x, 5/11 is already a fraction, so I don't need to do anything. 1 3/4, multiply 1 by 4, add 3. 1 times 4 is 4, plus 3 is 7. Keep the denominator, so 7/4.
Pardon the interruption, Matthew.
All right, so now I'm going to add those together. So how do you add fractions? Well, you need a common denominator. So we got to move over here. X equals 5/11, I'll just rewrite it, plus 7/4. So what you're going to do is you're going to try and get common denominators. What's a number that is shared by both 11 and 4? Well, 44, I don't know if that's the smallest one, but it's the easiest one because I know 11 times 4 is 44. So x equals, now how do you go from 11 to 44? Here, I'll go ahead. 11 to 44 is times 4. So I'm going to do the same thing for the denominator. 5 times 4 is 20. All right, now I'm going to get rid of those times 4 just because I think it clutters up the problem. All right, now do the same thing, plus sign. How do you go from 4 to 44? We'll do the same thing. Well, that's times 11. So if you do 7 times 11, that gives you 77. Let me just clean this up really quick. All right, so now we can add. That's easy. When you add fractions, you leave the denominator alone, so over 44, and then you just add the numerators. 20 plus 77 gives you 97. All right, how many times does, now we got to change that into an improper fraction. How many times does 44 go into 97? Well, it goes into 2 times because I know 44 times 2 is 88. 97, if you pull 88 out of 97, what do you have left over? Well, you have 9 left over, so 9 left over out of that 44. So, in this problem, I know this seems like a lot. X is equal to 2 and 9 over 44. Now, I'm not going to take that 2 and 9/44 and plug it back in for that x spot and double check, but you could do that. You could take that 2 and 9 over 44 and then add negative 1 3/4 to it, and you will get 5/11. All right, but this is not beyond the expectations. You should be able to do this. Now, this is a harder one of those problems, but it's kind of something that you should be able to do. All right, let me know if you have any questions.